mentioned, we spent a lot of time talking about the compute capability of our drive, but this at the end of the day is a drive. So we started with an ASIC. It was all ground up, as we've talked about, for various different reasons, but we had to make sure we had the right platform for it. So we'll talk through the different form factors of delivery for this particular product. Very important, firmware, and what we do with the firmware. It has to be reliable. We're a startup. People don't necessarily think that you know what you're doing. And if you're using an off-the-shelf controller, they only trust it as far as they can throw you, not them. So we have to have 100% ownership of it. I'll show you some examples of what I mean by the error-free floor, or error floor-free. Has to have a firmware. So we were talking about the QoS comment earlier. Here's an example of it in real time. You can see that our 99.9% is very tight. Now, if I put this graph in real time, that red hump of the competitive product occurs further down in the time frame. So they're faster. They're a couple microseconds faster than we are as far as the delivery of that response. But the width of our response is what customers care about. They don't care that it's actually a little slower. They want to see it extremely tight. So the drive around us, the red one, that's enterprise class, 16 channel. It's available on the market today from guys in blue and guys in green and wherever else you want to get it from. And so they're faster, but the customer didn't care. They wanted that tight window. So things like that are what we put a significant focus on. So you start with the building of the framework of an actual quality SSD product. Again, that's what this team has done multiple times before. Then we go and have some fun and we throw the in situ platform on it. And to Vladimir's point, there's 20 patents that sit associated with this particular platform to accomplish all of these tasks. And not all of those are in just the computational, they're in the entire stack. So we have the capability of having an IP portfolio that helps keep customers very intrigued. And then of course, the in situ has its points of interest from the way of the hardware acceleration, the ARM, the OS, and of course, lightweight virtualization capability.
Okay, a couple of questions about just as an SSD.
Yes.
Power fail and capacitor hold up?
So every drive has the capability to support PFAIL as customers want. If they don't want it, they don't have to get it because there are customers that like client class drives in their data centers. But we do support a full PFAIL capability in the drive. So full power backup. There is one thing that I actually don't have in here specifically in the way of a slide, but we have a patent on what we call an elastic FTL. So when you look at the drive itself, there's been a historical problem in the entire SSD world, and one reason why we're gated at capacities today of 1 gigabyte to 1 terabyte. You have to have a gig of DRAM to a terabyte of flash. That creates a problem for customers because I only have so much real estate, and we're not going bigger. You saw a presentation a while ago about some rulers, i.e. EDSFF, that we are also working on. They're real estate constrained. So how do we make that better? We actually have the capability to do 1/4 of a gigabyte to a terabyte. Or in other words, each gig of DRAM supports 4 terabytes of NAND. So now I have a lot more footprint on the drive to support NAND placements to get denser, and I'm consuming substantially less power. And because these drives are sitting at 4, 8, 16 terabytes, any added BOM cost to the rest of this architecture being a startup and margin on NAND I might have to worry about completely dissipate. And I have now that dollar per gig comparable product that Nader mentioned at the beginning of the presentation.
And that's separate from the RAM for the application processor,
yeah,
right?
Exactly.
Correct.
It also frees up space for us to have the RAM for the application.
Of course, at VMworld, they announced vSphere on ARM.
Yes. We're very excited about that. We need to start working on that.
And with 8 gig of
That's on the wish list.
Little tiny VMs in each.
So to add to that, this FTL, elastic FTL, the advantage that it brings in, it uses less DDR per terabyte, and doing this without impacting random read. That's the part that makes the huge difference in the world.
So again,
and most of the traffic of the data centers is more focused on the random read rather than random writes these days. That's the part that plays a critical role, especially in any of the form factor that has a small footprint, be it M.2 or a 8 terabytes or a EDSFF with 16 terabytes or 2.5 inch with 32 terabytes. Not having the need to put all the DDRs needed, that makes a huge difference, and from power consumption, cost, and real estate.
I had another question. You guys having any kind of compression technology or deduplication built in with the drives?
Not as a hardware. We have it that we can, because of the in situ, we can have different mechanism or different algorithm for the compression or decompression. Based on our history of doing 11 different controllers in the past, some of the enterprise customers, they don't want to use the encryption, so the compression. They actually ask to turn it off, especially if they are buying one set of the drive from one supplier, another set of drive from somebody else. If the compressions are not exactly the same, it's problematic for them. So because of that, we didn't put in as a hardware accelerator, but because of the in situ capability, we can implement it.
Thank you.
So each drive boots their Ubuntu from their own internal partition that's sitting on the flash, effectively?
That's correct.
Yep. They're self discovery basically. So I talked about the fact that we do the internal controller architecture. So this is where I get back to being when I used to be an engineer and I was a device physicist. So I have fun with this stuff too. So quick segue into media management and what that really means from an SSD. We're selling an SSD at the end of the day. So we have to be able to understand the media that we're using as well. So this is an example of some of the team and their ability to do characterization of TLC NAND with cycle count analysis. So what you're looking at here is cycling from 0 to hero, 0 to death of a given NAND device, and then seeing what we can do to correct and overcome faults with that particular media and provide that reliable drive to the customer. So the bathtub represents the usable life, with the 0 being kind of the normal, because everything's normalized. And then you have death and you have the I'm fast at the beginning of life type of parts. And what you're seeing here is this basically represents the capability to support with an off-the-shelf TLC part about 3 drive writes per day with simple device management. And it's not focused on the amount of OP, it's not focused on other things that you can do all kinds of other media management aspects of it, but just the raw media itself. This tiny little blip you see in the middle is actually where we're cycling parts and one of the blocks went bad right in the middle of the process. And we're still able to overcome it and ignore it in real time. So that's another thing that without an accurate firmware and without a core ownership of the firmware you're writing, you have problems when the media decides to throw a curveball at you and you still have to overcome it because the customer doesn't care that the media I bought came from X, Y, or Z. They care about the drive. And I have to support the drive because I'm not selling a controller. And people are very, very hot to trot. TLC is great, but we can do QLC too. So that's another fun part of it. You can see here this particular curve. That's roughly about a half drive write per day with QLC at scale and in volume with this particular capability that our ECC engines have and our media management tools are capable of. And then when you look at it from an LDPC perspective, there's this concept of an error floor in LDPC algorithms. And for those of you that aren't device physicists or algorithm specialists, you can see that you can correct to a certain point, and then there's a point where the errors start growing so quickly it becomes a floor. You cannot correct beyond that, and that sets your Uber for your particular device. And you can tell by over here, we have the modeling, we have our FPGA model off of a base code, and then the blue lines represent the patented IP that we have that supports this. You can see that our Uber capabilities and our raw bit error rates go substantially further down. We've yet to hit an error floor beyond 10 to the minus 19 with our ability to correct existing people's NAND in both TLC and QLC technology. So not only do we have in situ processing, do we have a very large drive that uses a little bit of DRAM, but it's one of the most reliable parts you can get because of the capability of our error correction within the drive.
So what's the spec sheet error rate?
We do minus 16 today because that's competitive with everyone in the market. So. Oh, forgot I had some pretty animation. So it's an NVMe SSD at the core. This is the one block diagram we've shown of the actual inside of the controller beyond just the actual management. And then, of course, all of the compute that we've added to it. So you can see we've split it into hardware resources and software resources within the architecture of the drive. The highlighted blue and orange represent what we can do with in situ on top of the base NVMe SSD. So they are dedicated, separate resources. We're not trying to share. Everything's done by its own interface, by its own talking. We have the real-time processors. There's your AES engine. And it's all run through a flash media controller that we have ownership of as well. So ground up design, completely isolated infrastructure to be able to support as an NVMe off-the-shelf drive at a very large density, or let's throw some compute at it and have some real fun with the product and the technology.
And the drives all ship with the in situ processing capability, and it's turned on or off depending on what the customer buys. Is that how it works, or?
Yep. Because the ASIC has this all built into it as a core ASIC, we can turn it on and off. And we're able to do that through both the software and or firmware. So we actually do have the products available in 2 unique platforms. One's a high capacity storage device, one's an intelligent storage device. And you can actually get the high capacity device as is with no intention of turning on the in situ resources for a bit of a savings, because at some of the customers just need a big drive or a reliable product, and they're never going to turn it on, so we're not going to charge them for those resources unless we know that they're going to use them. And so there's effectively a licensing model associated with the software half of the platform. And so when we look at it from what we actually deliver, he highlighted the form factors. This gives you the blow up of what those form factors look like. So the U.2, which is the most popular form factor today, we can do 32 terabytes today with TLC. I don't need QLC to do that today because I have the room on the board, complements of the lower DRAM footprint. It also sits at 12 watts, not 25, which is what the envelope offers. So I've just eliminated a lot of your power and energy problem, and that's where the watts per terabyte come into play. M.2 is very popular. We can do 8 terabytes in an M.2 today. That's just space constrained. If I got a denser die, I could do it. If I did QLC, I could go to 16. The EDSFF, we're doing the 1U short, which is officially called E1.S, is the new naming convention for that lovely puppy. So the short version, that's 16 terabytes today and capable of being delivered in 16 terabytes. We still have the add-in card for some folks, mainly because it's a really big drive, 64 terabyte capable in an add-in card. We've sold several customers a 32 terabyte drive already today. They've implemented them and they keep coming back for more because they just have large data sets they need to manage. And it's all built around a proprietary controller that we have in the way of what we call our Newport platform. So a little bit of history on the family of products, and you can see kind of in the banner we had a little bit of play on conquering the world. Our original product line was called the Catalina family, and we're Southern California based folks. Catalina is a very popular resort island off of the coast of Newport. So we brought Catalina to market, get your prototypes, get people interested in the marketplace. We're landing and taking on the rest of the world with the Newport ASIC-based platform. So at the end of the day, kind of wrap it up. We spent a whole bunch of time with you. I hope you still have some questions. Great. If not, we'll get you done a little bit early. But in situ processing, on-drive OS, container support, the Newport platform gives you the capability to have a little bit more fun with your drives and not just simply be a storage locker. Near data processing is very important to the future of the marketplace. We're not the only ones saying that. We didn't do a Gartner says. I stayed away from that. But I used other people to tell me. Finding the right partners. We didn't want to build a solution without a problem. We wanted to find a problem that needed a real solution. We found it as one partner that's willing to be open with us and be able to share a logo. To be able to do all this, we couldn't find anybody else that had a controller. So one of the beautiful parts of being a storage startup is we can think outside the box. I don't have an existing revenue train I have to keep going or a product I have to iterate on. I can start from ground up and build something new. And then, of course, at the end of the day, we believe it or not, power is becoming more and more important for us. We have a customer in Europe. He has a beautiful server that has 24 bays for drives. He can only put 4 drives in it today because his power budget for the rack lets him have 4 drives per server. When I have a nice low power drive at a very high density, I solve his capacity problem and stay within his power budget. Any other comments, feedback, questions that we didn't cover or you'd like to ask?
When will samples be available?
So we have prototypes now. We'll have the ASIC-based solutions by the end of the year, so Christmas presents for our customers.
Xbox? Xbox.
You know, I have a few touch points at the company, but there's a few more to go. If you know someone.
Okay, is the logo supposed to be a cloud or a UFO?
It depends. If you ask our board member, he thinks it's the top of an ice cream cone.
I like ice cream.
It is meant to be a cloud. We got to play on cloud, AI, all that fun stuff. It's the buzzwords, right? So yes, it is meant to be a cloud.
Currently have?
So the
I think it's a
market,
bowler hat.
Bowler hat.
Sorry, what's the?
Yeah, I was asking how many customers you currently have.
We have about a dozen customers. We are about to pass the $1 million mark revenue. Based on our prototype existing solution and getting ready, and we are actually getting POs for the mass production now.
Are you primarily focused on hyperscalers as a vertical, or is it?
No, but it's from this point, because of all the scars we have had for the development of the controller, we don't discriminate. So whatever customer comes. One of the main vertical is hyperscalers. The other vertical for us is content delivery providers, and the emerging up and coming is the edge of the network and fog with edge computing.
Yeah.
The intelligent edge, if you will.
Right. Right.
Yeah, I mean, I gotta say, just personal random opinion. It seems to be your biggest challenge is focusing. Like, I don't. It would be so hard not to get pulled in 16 million different directions.
Yeah. Speaking of how many
absolutely.
You just made Vladimir's day.
Yes.
I just picking which battles to hit first. That's the hardest part.
So one of the main thing, or the main focus has been to have proper set of tools as a bare minimum to hand over, so we don't get involved with the application porting portion, because we don't have the skill set, the scale, and the time. So that's really the main focus. But yes, absolutely correct. That's a challenge.
And to the point on focus, from the start of the company, the kind of cornerstone verticals we were going after were the hyperscale vertical, because we could define very easily for them. And then the intelligent edge, as it's become known, that type of market was the secondary footprint. So we've made most of our efforts in those two spaces. We've definitely been engaged with gaming, other types of applications, but we always come back to keep it simple, stupid, deliver first, and then you can start to expand.
Just avoid big customers.
Is it price differential between the regular capacity drive, high capacity drive, and the intelligent capacity? Is it based on terabytes, or is it just based on the fact you want to turn this on?
It is based on the terabytes, obviously.
So behind the storage device.
Behind the storage device, but it's minute, especially when you look at it for an 8 terabyte capacity or higher. The differential is very little. It's mostly to cover the cost of the software and all the support that we need to develop and support them.
And how many people in the team?
We have 36 people today.
You already told that. How many? The level of funding at the moment?
We have closed 2 rounds of financing so far. We have $25 million that we have secured, and we'll be looking at for the next year possibly to do another round for expansion of the really sales and marketing.
And where are the products available today? Where can it be purchased? Or
It's actually direct. So
Yeah.
talk to this gentleman, and he has a counterpart in sales.
Yeah.
They ask for POs.
From a global perspective, heavily focused on US and EMEA, we haven't really gone after the APAC side of things just yet. So engaging there, but we've been delivering product in both US and Europe today. We do have a couple rep firms that help support us because our sales force is small. Marketing department is standing in front of you, so we've been very careful about how we spend our VC money. As you mentioned, very few people have been able to turn an ASIC with as quote unquote little funding as we've been able to pull in. So.
Yeah.
So one other piece of topic that we haven't talked about. So if you remember at the beginning, our vision, we said our value proposition is lowest watt per terabyte and lowest dollar per gigabyte and intelligence. So because we don't have the flash media, so a lot of people would ask, how could we be cost competitive? So we have a unique business model that we, especially for large customers, we let them negotiate and procure the flash, they consign, and we provide the rest of the
Assembly and support.
And provide the solution, test that part back to them. So we don't add margin to the flash to be a business. We add obviously margin to the portion that we bring to the party, the controller, the firmware, the software, the putting the footprint of the complete drive and the testing portion of it. And that's the part that it's, because it's part of the disintegration of supply chain from the large data centers that are going after, that makes it huge difference for them and for us. And the fact that we are flash agnostic, it makes it much easier for them to qualify.
So you got 0.35 watts per terabyte. What's typical industry kinds of numbers?
About from 1.2 to 4.
No way.
So if you
Yes.
think about some of the products on the market today, you get an 8 terabyte, 2.5-inch NVMe drive at 25 watts. That's more than 3x what I'm showing here.
And when you have, again, it comes down to the total footprint of the physical footprint of number of servers and the racks, as well as the power density, because some of these large mega data centers, they have real estate, they have money to put plenty of servers. There is no power available to pull from the grid. So when they need to double or quadruple their capacity of the storage, that becomes a problem. The only way to go is more energy efficient storage devices.
And one of the biggest problems when you start talking about bigger and bigger, we all know the drives are getting bigger. 8 terabytes is normal today. We're talking 16, 32, 64. One of the key components of the architecture with the firmware is the ability to overcome those errors that occur because people worry about single point of failure or large parts of the devices going bad. Our actual design model for our 2.5-inch and our AIC card allow you to have removable, replaceable memory modules or storage modules, and there's a patent on that capability where you can actually pull off
Right, field replaceable memory?
Field replaceable. You know, it has to be pulled out of the system, powered off.
Yeah.
But you could remove a memory module, replace it with a new one, and the drive itself can recover the data that was on that module in the way of an ECC recovery error.
Whoa.
So,
Didn't say anything about
patent
that.
10,667,048 issued 2 weeks ago. So, yeah, we have some toys over here we'll show off after the recording's done, and you can see how we've put that together, that you can actually see the pseudo field replaceable units. That helps customers when they talk about big drives.